Hello, this is Walker Physics, 4th edition, and we're in Chapter 7 on work and kinetic energy, and this is the end of the chapter questions. Question number 7. Coefficient of kinetic friction between a suitcase and the floor is 0.7272. Suitcase has a mass of 71.5 kilograms. How far can it be pushed across the floor with 642 joules of work? Okay, if you remember that kinetic friction is the friction of sliding, okay, so that's once it's sliding, it's resisting the shove, okay, so if I have a box, on the floor, and that box is 71.5 kilograms, and I'm shoving on the box that way, then your friction force is going to go this way. So this is kinetic friction. And remember that kinetic friction is going to be your coefficient of kinetic friction times the normal force. And we're on the floor, so there's no angle here, so the normal force is going to be equal to the weight. So this is going to be equal to mg. So we've got kinetic friction equals the kinetic friction constant times the mass times gravity. All right, so this is 0.272 times 71.5 times 9.81. Okay, that gives you a total of 190.8 newtons. So this is what's pushing back, 190.8 newtons. Okay. All right, so you have work equals force times distance. Okay, so if I'm shoving this way with 190, then I must at least be shoving the same. Now, if there would be no acceleration, because it would be constant motion, it would be essentially there would be a force. You'd have to be at least 190.8. My brain thinks it needs to be a tiny bit more than 190.8, but at least it has to be equal to the friction coming back at it. Okay, it wouldn't accelerate; it would go at a constant speed. But at least whatever, not 190.8 going this way, you have to at least shove it back in the other direction at that same force. So I'm going to make this 190.8 times distance, and they give us 642 joules to work with. So I'm going to divide by 190.8, and I get a distance of 3.37 meters. 333. Okay. All right.